Okay, so now we're going to do a similar process, but we're going to do domain and range for a continuous graph. And this is going to look different than the previous one because it's not just a bunch of dots like the discrete graph. Now it's like we have a connected graph here, right? So this, I can draw on this whole thing without picking my marker up. And it's continuous because all the dots that we would have had have now been connected. It's like, it looks more like a line rather than just dots. Okay, so this is continuous. The process is different because on a continuous graph, there's really like an infinite number of points that I'm drawing in here that are just so close together that it looks like they're connected. But really, they're all individual points. And keep in mind, with my domain and range, I want to list every single x value and every single y value. Well, if my graph has an infinite number of points, I can't possibly list all of them. So instead of listing all of them, we're going to list the smallest and biggest x values and just say that we can be everything in between. Okay, same thing for the y values. We'll list the smallest and biggest y values, and we'll say we can be everything in between. That'll give us like two boundaries that we are in between rather than listing them all individually with numbers. So the notation, how we write it, is going to be a little bit different. Now let me show you for domain. Again, this is x, range is y. And I like to think of, for domain with my x values, since I'm going left to right, like x measures, I want to try to put walls on this graph, okay? So I want to capture the entire graph inside of these walls, and I want these walls as close together to accomplish that, as close together as I can without cutting any of the graph off. So I have this first wall. I'm going to put this on the right side. This graph stops at that point up at, what is it, 4, 10, that top point there. So here's my wall on the right side. And on my left side, a common mistake is to say that this wall belongs right here because that's the end of the graph that I can see on this paper. However, this arrow down here means that I ran out of space. This graph is going to go forever and ever and ever. So if I were to extend this a little bit more, it's going to keep going, right? Forever and ever and ever. So there really is no wall I can put on the left side. This is going to just keep going until it's off the screen. Okay. Now what that means is my smallest x value doesn't really exist. I keep going forever and ever and ever to the left. So we say that that's negative infinity. I never stop going to the left. It's going to be negative infinity. That's my smallest. Okay. My biggest value is where this wall is on the right side. So what I want to do is at this point, I want to see what that x value is. Let me move that wall a little bit to see it. I think that is 4 for my biggest x value. Smallest on the left, biggest on the right. Now, you're always going to use the same notation, less than signs with your variable trapped in between. And I'm using x right there because this is domain and it measures x values, okay? The only other thing you need to consider is, do I need these equal signs underneath? And the way that you can tell is, do you have an open or a closed circle? So let's talk about this point up here. That is a filled in closed circle. So that means I am including an x value of 4. And then for negative infinity, we're never ever going to include negative infinity, so I'm going to leave that without an underline underneath, okay, because that's similar to like an open circle. Okay, that means x can be everything in between negative infinity and positive 4, uninterrupted, every value in between. Next, let's talk about our range. I want to go tallest to smallest. Or I guess lowest to highest. So let's see. I erased my arrow. We had an arrow here. All right, I'm going to do floor and ceiling. Think about floor and ceiling. We're measuring height. So we'll do ceiling first. The ceiling I'd have to put right there at a value of 10. right? That's the tallest point. And then similarly to my lowest domain value, I think there's not really a floor I can put. Again, a common mistake would be the floor would go right here because that's where the line got drawn until. But again, this is going to continue. That's what that arrow means. It's going to go past that arrow forever and ever and ever off the page, and it is never going to stop. So again, I think there is no floor. So the lowest height that I'm going to have is going to be at negative infinity. The highest height, the highest y value is up there at 10. And then my signs I use are going to be less than signs with a y in the middle because we're talking about my range. And then the last part is, do I need underlines here? I do not need an underline in this position because we can't equal negative infinity. But I can be positive 10. That's where I have that closed in circle. So just take a look at the differences here from our discrete where we list the points individually, and then for continuous when I'm just listing the smallest and biggest x and y values with the difference in notation. So go ahead and try your continuous graph, and thank you.